Okay, good day everyone, and welcome to the comprehensive overview of Poynting's ePoint series, which is our CPE readily available antenna enclosures. But yeah, there's a lot to cover, so let's start with it. So we'll start with our ePNT-1 and 2. Look the same, sound the same, but completely different antenna solutions. But what exactly is our ePoints? So in a typical setup with let's say our normal fixed wireless access antenna, we'll have, let's say, for instance, our export to 5G antenna, which is a 2x2 MIMO antenna, and you will then normally have a 5-meter cable run going from your antenna to your router inside your home. Now, this long cable run of 5 meters can result in a 3 dB loss in gain, which is due to the cable losses and the cable run, and also depending on frequency, what you're using. And this is not very ideal or very efficient. And there can even be more losses if the coaxial cable of the antenna is also maybe damaged during installation or other aspects such as weather also. So that's the one thing. This is the standard way of doing normal fixed wireless access installations with antennas. However, we at Poynting a few years ago launched our ePoint series, and we'd want to eliminate that loss of cable. So the ePoint series was designed to remove the effect of cable loss and also improve the overall RF performance, where a customer can combine their world-class router with our world-class antennas. So start off, let's say you have your normal ePoint. You take off, what we've done is we've actually created space inside the housing in the back of the antenna for a router to be installed. So you would actually take off the housing or take off the back cover, install your router, which is able to fit inside the ePoint-1 or 2, connect the antennas that are available, which is cellular, Wi-Fi, and whatever you need. Close it back up, have only an Ethernet cable coming out, because with an Ethernet cable, there are actually no cable losses. Then yeah, you have a perfect CPE-ready solution, and this can be used to provide you with perfect signal-to-noise ratio and improved RF performance. So let's start with the ePoint-1 and our ePoint-2. So the ePoint-1 is it's actually an omnidirectional solution. It does contain 4 cellular antennas as well as 2 Wi-Fi antennas. And the cellular antennas work from 617 all the way to 3,800 megahertz, while the Wi-Fi antennas are dual band Wi-Fi, so 2.4 gigahertz and also 5 to 7.2 gig. And you can see here, so the ePoint-1 is actually an omnidirectional cross-polarized antenna with 4 omnis in there. So 4 cross-polarized omnis in there, vertical, horizontal, and plus minus 45. And then we have a 2x2 MIMO Wi-Fi dual band antennas in there. So optional considerations is that you can use the Wi-Fi for IoT. We can also have there's a space here at the top. We have like a small faceplate coming out where we can actually install a GPS if your customer does require GPS. And then we also have SIM card extenders as optional accessories. So that's the ePoint-1. It's an omnidirectional cross-polarized solution. Standard, nothing too new about that. And then another one is our ePoint-2. And this is a bit of a hybrid one, which makes use of directional and omnidirectional antennas. So the ePoint-2 also contains cellular and Wi-Fi antennas. So the cellular antennas also operate from 617 all the way to 3,800 megahertz, while the Wi-Fi antennas are again dual band, covering the 2.4 gigahertz band and also the 5 to 7.2. So you can see there, it's a total of 4x4 MIMO solution, so 2 unidirectional and 2 omnidirectional antennas, and also additional 2x2 MIMO Wi-Fi dual band antennas. And the same as the previous one, we have the optional accessories of the GPS antennas that can be included, or SIM card extenders that can be bought separately. So the ePoint-1 and 2 very much they look the same, sound same, but they're not the same. But they can be used in a variety of applications, or industries, for instance, urban and rural, farming, agricultural, or commercial or industrial usage. So yeah, by including your router inside these, you can have a complete CPE solution in any of these areas. But what are they actually performing like? The ePoint-1 is the omnidirectional antennas operate, as mentioned, from 617 all the way to 3,800 megahertz. As you can see, it's perfectly matched across the entire range, below 2.5 to 1, with a VSWR below 2.5 to 1 over 90% of the band, and with a peak gain of 4.5 dBi in the midband. Now you might be thinking, gee, this is it's not high gain, but I mean, if you're taking into account there are no more 3 dB losses due to cable loss, there should actually be, you would need a 6 dBi peak gain omni antenna to get the same performance as this. So yeah, I mean, removing those cable runs already supplies you with a perfect no losses antenna solution. Now, pattern-wise, how are the patterns on these omni antennas in the E.1? You can see the cellular antennas, they are perfectly omni. On the elevation, so the elevation is the side view, looking at the antenna from the side, you can see the ideal would be to have the lobes with all the power concentrated on the horizon, as you can see here. So it should look like a donut or an apple cut in half. And yeah, it's perfectly omnidirectional as you would want, with all your power being radiated on the sides, not being up and down or to the moon and to the ground. And yes, and then you can see these are actual measured results, not simulated results. And then when looking at the top view, the azimuth radiation pattern, you can see again you would want a perfectly omnicircle. And yeah, that's what you can expect with our E.1. So perfectly omnidirectional coverage on that with all the omnidirectional antennas in there. Now moving on to the E.2, now this makes use of if you remember, it's a directional and omnidirectional antennas. So the omnidirectional antennas included in the E.1, we then make use of 2 of those inside the E.2, and then they make use of 2 directional antennas, which actually come from our famous export 2 5G antenna. And you can see here these antennas are perfectly matched across, again, where it's from 617 to 960 megahertz, and then again from 1710 up to 4.2 megahertz, 4,200 megahertz. And the gain here is significantly higher than the Omni. But yeah, I mean, again, if you're taking this putting this into a CPE, you don't have the 3 dB loss or cable losses. So I mean, connecting a router directly at the port with this, you would get the best out of your router and also out of the antennas. I mean, there's no cable losses, so this is quite ideal. But yeah, that's performance is actually fantastic. You can see 9 dBi max in the low band, 8.5 in the mid band, and around about 11 there in the high band. So this is a fantastic directional antenna, high gain. And looking at the patterns on the E.2 directional antennas, you can see that side view, the elevation radiation pattern. You can see again that you would want everything concentrated on where it's facing towards. So in the side view here, it's perfectly across all the frequency ranges from 617 all the way to 4,200. It's perfectly directional with all the power being radiated to where the antenna is facing, and that's what you want. And again, with the top view, exactly the same. You would want all your radiated power going towards the front of where your antennas are and where it's facing. And this is, yeah, a fantastic directional antenna that you can pair your router with. And then with the Wi-Fi antennas, the E.1 and 2 also includes each one includes 2 Wi-Fi antennas, as can be seen here. And the performance on the Wi-Fi antenna is actually fantastic. You can see it's 2.4 gig band, and then also 5 to 7.2 with fantastic gain. I mean, it's 3 dBi 2.4 and up to 7 dBi in the 5 to 7.2 gigahertz band. So yeah, we're making it ready for Wi-Fi 6E applications on your router. And yeah, the idea behind the Wi-Fi is that the cellular antennas on the E-points connect to the base stations or wherever the base stations are, and then the Wi-Fi antennas are then connected to the Wi-Fi ports on your router, which will then provide the Wi-Fi to the facility around it, where your customers or you can just connect to your Wi-Fi on your router. And then on the mechanical data, it's not that big. I mean, it's the same size-wise as our Export 2. It makes use of the same exact radome. We just changed the back cover to make it a bit more bigger at the back to give space for a router to be mounted inside. So it's not that big a solution. It's actually quite neat and simple. And then on the router side, you can see that the available space inside is 185 millimeters by 145 millimeters by 45 in height. And we've also included some pre-drilled holes inside our E.1 and 2 for some popular routers that can't fit inside there. And yeah, just to make customers' lives a bit easier and just to quickly and easily secure their routers. But yeah, you can have a look and see if your routers do fit in there. Otherwise, you can drill your additional holes into the back cover if your router or modem does not fit into any of those holes. And then, yeah, just a bit of a recap on the E.12 over. So the universal router size, you can see there's 185 by 145 by 45 millimeters. So this is a universal router spacing. So if your router is more than that, it will be able to fit inside the E.102. And enclosure size, it's fairly a small and neat solution. Then on the mounting options, how can these these CPE solutions actually be mounted? So we have the back cover actually is a unique way it was designed. So it can be pole mounted or wall mounted. You can see it's indented there, so wall or pole mounted. And we also include additionally window suckers to have these window mounted. But this is mainly for fixed installations. You can't use the window suckers on a vehicle outside of a vehicle because yeah, that's not recommended. But this is mainly for fixed installations or temporary installations. What are key selling points on the E.1 and 2? So it will give you better signal levels, higher speeds, lower latencies due to the removal of the cable losses. The universal router housed internally, so no more cable loss and limitations. It's an easy installation for quick deployment, so flexibility in antenna placement without cable restrictions, versatility for outdoor and temporary applications, and it extends reach where fiber can't, and an internal router housing for a clutter-free, high-performance experience. So it's faster, it's easier, it's more cost-effective, and network to set up. So you install the router inside the ePoint and on the ground, connect everything, take it up, install, and then you're good to go. Just have your Ethernet cable coming out. And then just a simplified network planning with reduced stock space, maintenance, troubleshooting, and repair costs. And also prioritizing performance across supported frequencies while maintaining durability, flexibility, and reliability. Yeah, I think this is a fantastic solutions. We might have been ahead of our time when we launched the E.1 and 2 2 years ago, but from a customer point of view, this is just, I think, a fantastic solution because it can get the best out of your router and out of your antennas with the removal of all those cable losses and inside a complete package. But that's not the end of it. So we have the E.1 and 2. We also have our E.4, which is a bit of a different form factor, but it's also for different market segments. So what is the E.4? So the E.4 is it's very much the same as our E.1 and 2. It's just, as I said, completely different form factor. It's it's an all omni antenna that we have in the E.4. So it's cross-polarized omnis for optimum coverage, and it's also an IP67 waterproof and dust-proof housing for your router and a UV stable radar. So what's the housing the router inside the antenna? So what's the benefit of housing the router inside? Again, lower cable loss, higher throughputs, and just a cleaner installation site overall. So as mentioned, the E.4 is a omnidirectional antenna, so the antenna is included in the E.4. We have two different configurations, but we have cellular antennas and Wi-Fi antennas, and the cellular antennas operate from 617 all the way to 4,200 megahertz, while the Wi-Fi antennas are again dual band, and now it only covers 2.4 and 5 to 6 gigs. Now, as mentioned, we have two different configurations on the E.4. We have the E.4-15, which includes two cellular ports, two Wi-Fi ports, and one GPS. And then we have the E.4-17, which has four cellular ports, two Wi-Fi ports, and a GPS port. Now, the E.4 can be used in also very much the same verticals as the E.1 and 2. However, it also now includes marine. So again, urban and rural, marine and coastal, farming and agricultural, and also commercial and industrial. So quite a wide variety of verticals that this antenna E-point solution does cover. So what's the actual performance like on the antennas? What are the measured results on the E.4? So as mentioned, the cellular antennas, again, it's operating from 617 megahertz all the way to 4,200 megahertz. And the gain is, if one would say this is quite low gain. What benefit will this have? And again, you can see, as mentioned, if you remove the cable losses of, let's say, can go a minimum of 3 dB loss you get with the cables, you would need a fairly big and substantial antenna to accommodate, well, all the amount of antennas and also the performance that you would be getting if you were to compare this with a standard Omni. So yeah, with you would get approximately 1 dBi gain in the low band, so 6.7 to 960, and then around about 3 dBi in the mid band, and peaking around about 0 in the high band. But I mean, that's still, if one thinks 0 is bad, but that's good. You still get good reception. There's no cable loss now, so you would get good coverage with your antenna across all the frequency ranges here. And then again on the patterns, how does this actually radiate? And you can see the patterns are again beautiful omnidirectional patterns on the side view. At the top you have the elevation again. So you can see the patterns are absolutely constant from 617 all the way to, this is now to 3,800 or 3,700. You can see the patterns, the majority of the energy are at bore sites, is at the bore side of the antenna. So you're not wasting any antenna performance by radiating the antennas upwards or downwards. Everything is on the horizon where it should be. And then looking at the below, you have the azimuth, and again, perfectly omni. And this is what you want, especially let's say for marine applications. You have this on a vessel. You don't want a dead spot somewhere on your antenna, because let's say it's connected on that band and you turn, you might lose complete, well, connection to your base station because of that dead spot. So with this, you can see it's perfectly omni, and this will ensure that you have constant connection no matter how you mount the antenna. And yeah, and as mentioned, as always, these are our actual measured results. These aren't simulated simulated patterns. Again, on the Wi-Fi antennas, these are again fantastic. There's two Wi-Fi antennas with the 15 and the 17. So again, the Wi-Fi antennas are there to provide Wi-Fi coverage to the users around the ePoints, or from the router to your phone, or whatever is connected to the Wi-Fi. And again, the Wi-Fi antennas are also, yeah, the patterns there is also quite, it's breaking up here and there, but it's not massive dips. It's not that bad. But yeah, the Wi-Fi antennas are going quite well. So the overall size of the E.4 is actually fairly a small solution, to be honest. It's around about the same height as the E.1 or 2, but it's a nice, sleek design, sleek form factor, and it's IP67 rated, so it's actually quite nice and looks fairly great. It comes with a unique bracket at the back. This stand here, or the support here from the back, from the bracket that's connected to the antenna. This is actually a feed through for your cable, so you can secure your cable there and make sure your cable is then secured from outside in conditions. And then on the router side, it does have a bit of a smaller space available as opposed to the E.1 and 2. So the available space inside the E.4, we do include like a cradle there where the routers can be mounted or fixed onto it, which is 120 by 120. But the available space, your router cannot exceed 140 by 120 by 50. So I mean, there can be a bit of an overhang on the one side, but yeah, 140 by 120 by 50 is our recommended size. Well, the router size inside our E.4. I mean, the routers that actually do fit in is, for instance, like the Teltonika RUTX50, which is quite a big router, but it fits perfectly inside here, and it makes a great solution for customers. So mounting options, what do we have on the mounting options for the E.4? Much the same as that of the E.1 and 2. So you will have this bracket can be used for wall mounting or also pole mounting. So we do include knock-in screws as well as U-bolts for the pole mounting. And then also surface mounted. It can just be surface mounted onto any surface with just the Ethernet cable coming out. And then with newer E.4s coming out soon, we will be bringing out a stainless steel, a 316 stainless steel bracket for marine usage. So customers can use that for marine applications where there are harsh vibrations and conditions, and just offer that extra rigidity and ruggedness to your E.4 solution. Now, yeah, these on the environmental specifications, the antennas they have been treated and tested against extreme conditions of properties invisible to customers, but cause failures much later. So wind and water are designed to withstand winds of up to 160 kilometers an hour, and it's also water resistant with an IP67 rating. Rust and corrosion, it was designed for salt water spray, so E.4 is salt water protected with the UV stable ASA and also the 316 materials. Sun-wise or UV radiation-wise, UV protection, and so it has offer UV protection with the radio material we use, so the enclosure does not become brittle or yellow after a while. And it's a high-quality design and materials of manufacturing it using on the E.4. So what are the key benefits and takeaways on the E.4? It's a self-contained omnidirectional 5G LTE and Wi-Fi enclosure that integrates both your antenna and your customer router within an outdoor enclosure. So it's compatible with various router boxes and naked router PCBs as well. So it does offer wideband coverage for 5G LTE and Wi-Fi. It does offer 4x4 MIMO cross-polarization. So the antennas are cross-polarized, so this will allow for optimal signal reception and improved throughput. It's exceptional performance across the whole band, which is excellent for carrier aggregation, and is negligible coaxial cable losses between the router and the antennas, which will allow for enhanced RF performance. Thank you all. I hope that you enjoyed this overview of our ePoint series. And yeah, follow us on all our social media platforms to stay up to date with the latest news. Thank you.